Good morning, afternoon, evening, whatever time it is for you watching this, and welcome to another set of notes in our weather unit. Today, we're going to be talking about air masses and fronts, which are really going to help us understand weather patterns in general. So, if you are at least a little bit interested in weather, then you're probably most interested in how things like tornadoes and hurricanes and cyclones work. And we're going to get there, I promise. But before we can understand extreme weather, we have to understand what drives daily weather, particularly in the middle latitudes. When I say middle latitudes, that refers to everything between Florida and Alaska. So all of the US pretty much is covered by this middle latitudes term. In general, weather in the middle latitudes will be characterized by some constant weather conditions, a short period of change, and then a new set of constant weather conditions. So if I look at the weather app on my phone right now, I remember last week the weather was pretty much sunny, cloudless, nice temperatures all week. Looking ahead, it looks like that's going to be true today and tomorrow. Today is Monday, so even through Tuesday and Wednesday a bit, and then Thursday and Friday, it's going to be windy and then stormy, and then after that, it is sunny and mid 70s again. So that is what I mean by constant weather conditions all of last week, start of this week, sunny, nice temperature out, short period of change, couple days of wind and storms, and then a new set of normal weather conditions. All of this is pretty much determined by air masses. An air mass is a huge body of air up to 1,600 kilometers across. That is, everything in that air mass is the same temperature and the same humidity at a given altitude. So it usually takes several days for an air mass to pass over, and that's what explains this weather pattern. We have constant weather while the air mass is moving over us. We get a new air mass moving in, so there's a short period, a couple days of change, and then things settle down as we have a different air mass resting over top. There are four kinds of air masses, and there are two ways to categorize them. An air mass can either be continental or maritime, and that has to do with does it come from over land, like this one over Mexico and this one over Canada, or does it come from over water, like these coming from over the ocean or the Gulf of Mexico? The second way to categorize is does it come from the poles or does it come from the tropics? If it comes from the poles, it is going to be cooler air. And if it comes from the tropics or from the equator, it's going to be warmer air. So putting those things together, we end up with four different kinds of air masses. There is the continental tropical, which is a smaller air mass and it comes up from over Mexico and Central America. It is continental, so it is dry. It does not really carry any moisture with it. And it is tropical. It is coming from the equator, so it is a hot air mass. This air mass is really the main reason why Arizona, New Mexico, the Mojave Desert, West Texas are all dry and arid places. Another not as influential air mass is the maritime polar. This is coming from the north, from the poles. It is polar, which means it's going to be colder. And it's maritime, which means it's coming from over the ocean. So it's going to carry a lot of moisture with it. So these are going to be humid air masses. So cool and humid air masses. These really only have an effect on the northeast and northwest of the country. You might be familiar with the idea that Seattle and Portland are always cold, gray, and rainy. That's because of this air mass. It is cold and it is humid. It has a lot of moisture. So we've got the cold, rainy northwest, and in the northeast, we get storms that are called nor'easters, and these are these big, wet, cold storms, like huge blizzards in the winter. The two most influential air masses in the US are the continental polar and the maritime tropical air masses. The continental polar comes down from over Canada and Greenland, so it is continental, it is dry, it doesn't carry a lot of moisture, and it's polar, so it's cold. This one can push as far south as Texas, even. It brings cold air down through the Great Plains in the US. It's what gives harsh weathers in the northern states, and it brings us a nice cool breeze or a couple of days of relief during the summer. The maritime tropical air masses are warm because they're tropical, humid, carrying a lot of moisture because they are maritime, coming from over the ocean. These are a little bit more unstable air, so they are the source of almost all of the precipitation in the US. Pretty much all of the precipitation in the US is because of these maritime tropical air masses. They bring humidity in the summer, especially along the East Coast, where it can get incredibly humid during the summer. That's because of this air mass. And if it weren't for the Gulf of Mexico and this maritime tropical air mass, then most of Texas would be like Arizona and New Mexico and just practically a desert. This kind of hints at it a little bit, but where the continental polar and the maritime tropical meet in the middle of the US can cause some pretty extreme weather, which is why central US is often called Tornado Alley. And we'll talk more about that next week. Fronts are the boundaries that separate air masses. So when two air masses run into each other, they don't really mix. They both stay their own temperature and their own moisture level. So they run into each other, and one air mass is going to get pushed up. And that happens at a front. On a weather map, fronts are shown as long colored lines, typically blue, red, or purple. And they aren't really mixing. The cold air is going to form a slope that the warm air will get pushed up. So no matter what kind of front it is, warm air is getting pushed up and cold air is staying down, doing the pushing up. So first we have a warm front. A warm front, you've got warm air that is moving in this direction. On a weather map, it is shown by this red line with red semicircles. The semicircles are on the side of the line that show which way the front is moving. So it is pushing forward. The semicircles are on that side. And that is a warm front. It is a not as steep slope that the warm air is getting pushed up on top of this cold air mass. And if you imagine you live here as a warm front is approaching, you're first going to notice some cirrus clouds. As the warm front continues to move closer, they'll become cirrostratus and altostratus clouds until eventually you have some nimbostratus clouds and some precipitation. Not really violent storms, just a rainy day. And then once the front has passed and you are on the other side, it is going to be warmer. Temperature and moisture will generally increase pretty gradually, so warmer and a little bit more humid as the warm front passes over you. Next, we've got a cold front. Cold fronts generally move faster than warm fronts. You can see this is a much steeper slope than the last one, which means the warm air over here is going to be pushed up much more rapidly, which will give you some more violent storms and heavy precipitation. So more thunderstorms, more extreme. So I've got cold air now is pushing forward. On a weather map, it is a blue line with triangles, or some people call them the shark teeth. You can remember that because it is the biting cold, the way shark teeth are biting. So as this moves towards you, first, again, you might notice some cirrus and cirrostratus clouds, but this is moving faster, so it's going to take less time between the changes. As the cold front passes, you're going to have those extreme storms, lots of violent precipitation. And once you're on the other side, the storms will subside and it's just going to be colder and more stable air. Also, as the cold front is approaching, you're going to have wind pushing up towards, following the warm air and pushing up towards the cold front. The third kind of front is a stationary front. This one isn't moving, it's stationary. You have a cold front pushing one way, a warm front pushing the other way. They run into each other, and can't really move because they are pushing in opposite directions. It can give precipitation, but it's more likely to be those kinds of gray, cloudy days where it seems like the air is just still. That is a stationary front. On the weather map, it is going to be alternating red semicircles and blue shark teeth or blue triangles. So it will go back and forth, showing which direction each front is moving, but they will be opposite each other because they are pushing against each other and things aren't moving. The last kind of front is probably the most complicated. It is an occluded front. So here we have a high energy cold front that is overtaking or catching up to a warm front. So I had a warm front down here that was moving in this direction, warm front moving that way, cold front behind the warm front, but it's moving faster, so it catches up and it overtakes the warm front. So now I'm actually dealing with 3 different air masses. I have the cold air that my warm front was moving up over, and then I've got some very cold air that the cold front behind was catching up with. So the cold front catches up with the warm front. The warm air gets pushed up in between the 2 pieces of cold air, and you get widespread clouds and precipitation. On the weather map, that is a purple line with both teeth, both triangles, and semicircles, because it is both kinds of fronts pushed together. The last thing you really need to know about typical daily weather patterns is something called a mid-latitude cyclone. Remember, mid-latitude describes pretty much all of the United States. So a mid-latitude cyclone, we said before, is a low pressure center. These are large low pressure centers that move from west to east across the planet and across the US and last a couple of days to maybe just over a week. Remember that low pressure systems rotate counterclockwise. So these are all going to be moving counterclockwise. Typically, they've got a a cold front that extends, and there will be a warm front also. And then there will be some convergence and uplifting. Remember, in a cold front, the air moves up to give you clouds and precipitation. So this convergence and forceful lifting will cause heavy precipitation. And it follows a pretty typical life cycle. So first, I've got warm air and cold air that are moving parallel to each other, which is going to give me a stationary front. They're not really moving against each other. They are just right next to each other. Then there's going to be some disturbance. Something is going to upset that balance and they aren't going to be stationary anymore. The warm air, the warm front, is going to start moving towards the North Pole, and the cold air is going to start moving towards the equator, which is going to give us low pressure in the middle of the 2 fronts. The cold front moves faster, and so it overtakes the warm front, which gives us that occluded front. And you get a cyclone, remember, which just means low pressure center. And the cyclone is at its maximum intensity when you have this occluded front. Warm air gets lifted, the front ceases to exist because the warm air isn't part of the picture anymore, and the cyclone dissipates. So to see that in pictures, here I have my stationary front where the warm air and cold air are kind of pushing against each other, moving kind of parallel, but nothing's moving. Then there's some disturbance, and the warm front starts to push towards the north, while the cold front starts to push towards the equator. A low pressure center forms, a cyclone forms, and remember, around a cyclone, air moves counterclockwise. So I can see I've got a kind of counterclockwise circle here. It keeps moving, but the cold front moves faster, so it is starting to catch up to the warm front. I get my occluded front, And this is when we have the highest intensity of this low pressure zone. So we're going to have lots of precipitation. And then eventually the warm front is entirely dissipated. It goes away. We lose all our energy and things settle down. This does track across the US as it moves. Typically, they start on the western coast, and most of the time they can make it all the way through the country, all the way to the east coast. Sometimes it will dissipate not on the coast, but most of the time it will make it all the way across the continent. So we have a stationary front developing on the west coast around the mountains. It has something happens and the stationary front is no longer stationary. The low pressure center starts to form over the Great Plains. We start to get the occluded front a little bit more towards the Midwest, and at the coast and over the ocean, it starts to dissipate. And that is what you need to know about air masses, fronts, and mid-latitude cyclones. And next week, we're going to get into extreme weather. Bye.